Well, something created the universe or the universe is, here. How did it come to be? You could say whatever caused the universe to come to be is God or, gods, depending on your view. The tech billionaire wants to take humanity to the stars. So why isn't he taking full advantage of the James Webb Telescope's recent discoveries? We got to look at some captivating images as Webb peers back toward the origin of everything. This groundbreaking machine has become infamous for the unprecedented details it captures from the reaches of the cosmos, but it has uncovered a shocking new image that finally brought Elon Musk out of his slumber. Rumors are swirling that Musk's response to this image may hold the key to unlocking its secrets. But what exactly is the connection, and what does it mean? Join us as we delve into the mystery surrounding his reaction to the Webb telescope's latest discovery. If you trace back through history and popular culture, you can easily tell that humanity has always been fascinated and haunted by the thought of traveling through space. But it's only recently that humans have begun to understand just how massive the full reach of the galaxies is. The Webb telescope was highly anticipated as an update to the Hubble, and it has proven to be a transformative tool in astronomy. Scientists have had high expectations for the groundbreaking discoveries it would unveil. However, its latest findings have exceeded the expectations anyone could have had. According to Elon Musk, the Webb telescope has given us glimpses of what remarkable revelations it has uncovered, granting us an unparalleled view of the cosmos. And how will this new knowledge impact our society? Elon Musk is probably one of the wealthiest people in the world, but his interests diverge from the conventional displays of opulence often associated with extreme wealth. While others may flaunt their overall possessions like Bezos's luxury yacht or his expensive private planes, Musk's passions are a bit more unconventional. The tech genius is interested in things far beyond Earth's confines, so it comes as no surprise that he's taken an interest in the images of the vast expanse beyond our known galaxies. These images show the immense and awe-inspiring nature of our universe. On July 13th, Musk expressed his excitement for this significant breakthrough on Twitter, stating that he was extremely fascinated by the potential he sees in NASA Webb. As a prominent figure in the aerospace industry and a strong advocate for interplanetary exploration, Musk recognized this event as a crucial milestone in humanity's quest to explore the cosmos, and rightfully so. At last, we possess a telescope with the capability to capture more than 7 times the amount of interstellar light as its predecessor, the Hubble Space Telescope. Another big difference between these two instruments is that unlike the Hubble, the Webb is outfitted with an array of advanced cameras and other specialized instruments capable of detecting even the faintest infrared light and heat radiation. This isn't to undermine the achievements of the Hubble. In its prime, the Hubble Space Telescope was a remarkable feat of human innovation, offering us some of the most awe-inspiring glimpses of the universe beyond our comprehension. However, after 3 decades, its reign as the most powerful telescope in Earth's orbit has rightfully come to an end. As the universe continues to expand, light once visible to the Hubble has begun to fade from its view. It was high time for humanity to advance to a more potent telescope that could unveil the mysteries of the cosmos and beyond, and the James Webb Space Telescope emerged as the solution. The James Webb Space Telescope has shed new light on some of the most remarkable discoveries in space exploration since commencing its scientific operations earlier this summer. Most recently, the Webb team delved into Titan's murky atmosphere using the telescope's infrared vision, uncovering what appears to be a methane sea, sand dunes, and clouds. With a price tag of $10 billion, this observatory has also captured breathtaking images in remarkable detail and vivid color, including some of the earliest galaxies to exist less than 500 million years after the Big Bang and the stellar nurseries of the Carina Nebula. Understanding the telescope's capabilities, Neil deGrasse Tyson, the director of the Hayden Planetarium in New York, highlighted that due to the complexity of the mission, expectations were cautiously managed in case of any setbacks. He previously conveyed to Fox News Digital that the telescope surpassed our anticipations by adhering to the design specifications. So, upon examining those images, it becomes apparent that we are entering a new era of astrophysics. We are unlocking a previously inaccessible window into the universe. Developed as a collaborative effort between NASA, the European Space Agency, and the Canadian Space Agency, the James Webb Space Telescope was deployed into orbit in December 2021, following in the footsteps of the Hubble telescope. Bill Nelson, NASA's administrator, has lauded the telescope's capability to peer back over 13 billion light-years. The Near-Infrared Camera, or NIRCam, enables researchers to uncover some of the Hubble Space Telescope's most renowned discoveries. Tyson emphasized that while humans cannot perceive ultraviolet light, the Hubble Space Telescope possesses this ability. Telescopes are meticulously calibrated to observe the universe across various light wavelengths. The distinguished scientist asserted that the James Webb Space Telescope translates colors to render images visible to the human eye. The brain first creates an image using 3 bands of light, and then combines them to produce a full-color image utilizing RGB coding on computers. This process can be applied to any 3 bands across the spectrum. Numerous infrared images unveil galaxies previously concealed by dust or clouds. Among the striking deep-field images is a magnificent spiral galaxy filled with minute pinpricks of light. But the main question here is, when scientists study galaxies from a cosmos less than 1 billion years old, are they peering into some of the oldest galaxies in the universe? The light we observe from the most distant galaxies is essentially the oldest light emanating from stars, traveling for 13 billion years. It represents the earliest emissions from the newest galaxies. He emphasizes the significance of distinguishing between the terms old and new when considering newly formed galaxies continuously emitting light for 13 billion years. According to scientists, every image received from the early universe by the Webb telescope has been awe-inspiring. The telescope's design is specifically tailored to detect infrared light. They point out a temporal discontinuity in which Earth is unable to acquire high-quality data from the early cosmos due to the release of UV light during star and galaxy formation. As these light waves traverse expanding space since the Big Bang, they progressively shift to longer wavelengths, ultimately reaching us as infrared radiation. Webb has been peering into galaxies that formed over 13 billion years ago, plus it's given us a fresh perspective on our own solar system. Elon believes that it's a door to a new era of astrophysics, showing us high-res, top-notch data. These game-changing images mark the beginning of a new era in space exploration, revealing the universe with unprecedented clarity. But they're not just pretty pictures. They offer a glimpse into the universe's early days, a topic Musk has dabbled in. These images reveal over 1,000 galaxies, with one dating back to the Big Bang itself. NASA calls it the deepest and clearest infrared image of the early universe ever captured. And get this, it only took Webb less than a day to snap it. This marks Webb's debut image release as we dive into the universe, dubbed Webb's first deep field. The initial image features the galaxy cluster SMACS 0723, later checked out by President Joe Biden. This colorful image showcases distant subjects like the Southern Ring Nebula, Stephan's Quintet, and the Carina Nebula. NASA's social media exploded with excitement, with tweets like "Geeking out yet?" and "Our minds are blown," highlighting the image's jaw-dropping impact. The Webb telescope currently orbits the Sun at a distance of approximately 1.6 million kilometers from Earth, stationed in what is known as the second Lagrange point. This state-of-the-art observatory represents a collaborative effort between the space agencies of the United States, Europe, and Canada, with a price tag estimated to exceed $10 billion. The construction and deployment of the Webb telescope rank among the most costly scientific endeavors ever undertaken, trailing only slightly behind monumental projects like the Large Hadron Collider at CERN. Designed with a specific focus on capturing infrared light in the universe, a domain inaccessible to the naked eye, the Webb telescope has swiftly proven its worth. In just half a year of operation, it has delved deep into the cosmos, revealing light emitted over 13.5 billion years ago, offering unparalleled insights into the universe's distant past. Shifting our focus to Elon Musk, he initially praised the telescope's huge possibilities, but later seemed more cautious after seeing its groundbreaking images. In a bit of a surprise move, Musk tweeted just 2 days after the images came out, sharing a controversial photo of a kitchen slab. Here is your text formatted into paragraphs. With a pattern resembling cosmic formations, accompanying the image was a sarcastic comment aimed at NASA. Nice try. This tweet sparked different reactions, with some seeing it as a playful joke while others saw it as a sharp criticism. One critic suggested, "Why not just retweet instead of cropping? It's easier," confirming that Musk had indeed borrowed the witty remark from another Twitter user and decided to crop it instead of sharing the whole meme. Musk is known for being quite stubborn, recently even sharing his thoughts on YouTube, calling it a continuous flow of misleading ads, even though he could easily afford the YouTube Premium option. While Musk's opinion on the Webb telescope has shifted from praising its huge potential to downplaying its importance, there's no denying the breathtaking constellations it has captured. The images of SMX 0723 showed a sprawling galaxy cluster renowned among astronomers for its gravitational lensing effect. This phenomenon causes the cluster to distort and magnify light, making it appear much farther away than it actually is. Visually, it manifests as striking red arc-like formations, with light from these arcs having traveled distances of up to 13 billion years to reach us. Following this, we encounter the Carina Nebula, hailed as one of the most expansive and luminous nebulae in our celestial sphere. Positioned approximately 7,600 light-years from Earth, it comprises vast expanses of dust and gas where stellar births occur. Fondly referred to by astronomers as the cosmic cliff, its depiction by the Webb telescope is nothing short of mesmerizing. Subsequently, the Southern Ring appeared, serving as an inspiration for the trend-setting coffee tables currently being crafted by artisans across Europe. Essentially, the Southern Ring comprises an expanding shell of gas and dust bathed in the glow of a dying star nestled at its core. Spanning an impressive distance, the Southern Ring measures nearly half a light-year in diameter and resides over 2,000 light-years away from our planet. Despite being called a planetary nebula, the Southern Ring has nothing to do with planets. Its name comes from a mistake made in the early days of astronomy when telescopes weren't as good as they are now. Webb also captured Stephan's Quintet, a group of galaxies in the Pegasus constellation. It's worth noting that Stephan's Quintet is the first compact cluster of galaxies ever found, and here we see 5 of them. This is a closer galaxy in the foreground, and these 4 are at a distance of about 300 million light-years from us, and they're locked in a close interaction. What makes Stephan's Quintet so interesting is how its 5 galaxies interact, with 4 of them getting up close and personal in a cosmic dance. Using Webb's amazing ability to see in infrared, scientists studied the unique features of this galaxy cluster, something that was almost impossible with the Hubble telescope. Webb also showed off its skill in finding exoplanets that are far beyond Earth's atmosphere. Even some of the seemingly ordinary images from the telescope demonstrate its powerful spectroscopic abilities. Spectroscopy is all about breaking light into its different colors. This particular spectrum comes from the atmosphere of WASP 96b, a huge planet about 1,150 light-years away. It looks a lot like Jupiter, which neighbors us in space, and it's mostly made of gas. Webb's data collection on this planet was so advanced that scientists could pick out the different molecules in its atmosphere. Regrettably, WASP 96b isn't the type of planet suited for sustaining life. Firstly, it orbits very close to its parent star, resulting in scorching temperatures as part of its harsh environment. But still, this shows the significant role that Webb will play in the foreseeable future, aiding us in potentially identifying planets that share similar environmental conditions to Earth, and perhaps even uncovering signs of extraterrestrial life. Nevertheless, there's a possibility that Elon Musk could collaborate closely with NASA to chart a clear course for his Mars expeditions and potentially explore other celestial bodies with the aid of such a powerful telescope now at humanity's disposal. With ambitious plans for interplanetary exploration, there's a strong belief that Musk's newfound perspective on the Webb telescope should evolve. How do we grapple with the notion that we're peering into the distant past when observing celestial bodies, considering it might have taken millions or even billions of years for their light to reach us? Are they still thriving out there? Despite light zooming along at an impressive 299,792,458 meters per second, the universe is vast. The recent revelations from the James Webb Telescope could potentially revolutionize our comprehension of the universe's origins. Musk likened it to the distinctive signature of all the chemical processes occurring within those celestial bodies. He emphasized that it also offers insight into the chemical composition and its place within the cosmic expansion model. Recently, following limited disclosures from the White House about these objects, speculations about unidentified flying objects potentially having extraterrestrial origins began circulating. Although the White House later reaffirmed the absence of evidence for aliens or extraterrestrial phenomena, it provided no further elaboration. Moreover, the James Webb Space Telescope has provided astronomers with a glimpse into the cosmic path leading to a remarkable finding: the existence of massive, distant galaxies that defy expectations. These colossal structures took astronomers by surprise. Researchers are grappling with the challenge of pinpointing galaxies nearly as massive as our own Milky Way, teeming with mature red stars in the deep field images captured during the James Webb Space Telescope's initial observation phase. These galaxies appear as mere tiny reddish specks to the powerful telescope due to their extreme distance. These findings are detailed in a recent study based on the first data release from Webb's observations. Astronomers made a groundbreaking revelation. They were observing these galaxies a mere 500 to 700 million years after the Big Bang by analyzing the light emitted from them. The existence of such ancient galaxies isn't inherently surprising. During the universe's initial 400 million years, when only a dense fog of hydrogen atoms filled space, astronomers anticipated the emergence of the first star clusters shortly after the universe emerged from the so-called Dark Ages. However, the stars captured in Webb's images appeared exceedingly ancient, and the galaxies themselves were unexpectedly massive. Advanced predecessor, the Hubble Space Telescope, and they challenge established theories regarding the appearance and evolution of the cosmos during its infancy. Joel Leha, one of the authors of the study and an assistant professor of astronomy and astrophysics at Penn State, remarked that they had certain expectations regarding the kinds of galaxies that thrived in the early universe. They were expected to be young and petite. Hubble and other instruments often detected small, youthful, blue galaxies in the early cosmos. These entities had just emerged from the primordial cosmic broth and were in the process of forming their own stars and structures. Generally, the light emitted by young stars possesses a bluish hue. As stars age and deplete their fuel, they gradually cool down and take on a redder appearance. Webb was crafted to detect faraway galaxies, but astronomers were taken aback to discover such ancient crimson stars within them. Similarly, they were caught off guard by the revelation of galaxies with masses exceeding 1 billion suns. Yet the crimson dots observed in Webb's deep fields appear to be a staggering 50 times more massive than that. Scientists found that the biggest galaxies they studied had masses 2 to 4 times smaller than the Milky Way. They spotted galaxy contenders that were as big as our galaxy when the universe was only 3% of its current age. Before astronomers start rethinking their ideas about how these galaxies formed so quickly after the Big Bang, they need to make sure the strange red spots they're seeing aren't something else entirely. But it's worth noting that most other explanations also call for some new ideas. For example, because early universe stars didn't have many heavy elements, they might shine in different ways that we're not taking into account in our models. Or maybe the usual ways stars form, like how much gas turns into stars depending on a star's size, didn't matter much in the early universe. These discoveries would also be really exciting and, in a totally different way, would challenge what we know about how stars formed in the early universe. As part of the Cosmic Evolution Early Release Science Project, Webb's near-infrared camera took pictures of these puzzling galaxies. Soon, astronomers will turn Webb's mirror back toward these galaxies to learn more about their light spectra, split light into different colors, helping us understand more about where the light comes from and what it's made of. Just a few months after the Webb team unveiled the initial findings from the expansive observatory, scientists are already feeling the pressure to revise their understanding of the early cosmos. The colossal galaxies defy 99% of models of ancient galaxies in the universe, prompting researchers to reassess their hypothesis on galaxy formation and evolution. But that's not all from the James Webb Telescope. The more we uncover about Stephan's quintet of dark angels, the more we realize the grandeur and turmoil within this corner of our universe. Further investigations with the James Webb Space Telescope and the formidable Atacama Large Millimeter/Submillimeter Array, astronomers announced at the annual American Astronomical Society News Conference, have unveiled sheer chaos unfolding among these 5 brilliant galaxies. To start, one galaxy, NGC 731b, dubbed the Intruder, is unleashing a colossal shock wave spanning multiple Milky Way galaxies as it encroaches upon the space between the other 4 galaxies. There's quite a spectacle underway, as this immensely powerful wave has sparked a recycling hub for clouds of both warm and cold molecular hydrogen gas amidst the quintet. While a molecular cloud piercing through intergalactic gas and leaving chaos in its path may be rare and not fully comprehended, the data suggests significant progress in understanding the remarkable behavior and tumultuous life cycle of molecular gas clouds in Stephan's quintet. In an even weirder turn of events, the scientists stumbled upon a huge bunch of gas near the quintet, slowly falling apart as a separate tail of heated gas popped up nearby. To put it simply, this tail might mean there's a young galaxy hanging around, adding another layer to the crazy stuff happening in this far-off part of the universe, which is luckily between 39 million and 340 million light-years away from where you're sitting. One of the galaxies is actually much closer than its dancing buddies in the front row. Shock waves like the one smacking Stephan's quintet are usually made when an object zooms through a gassy area faster than the speed of sound. In this case, it's NGC 731b zooming through space at a crazy 800 kilometers per second, or almost 500 miles per second. According to the press release, you could get from Earth to the Moon in just 8 minutes at that speed. Back in 2006, using Spitzer, Caltech's astronomy team found something pretty cool. They spotted a ton of specific hydrogen molecules glowing in the infrared within the shock wave, along with X-ray emissions that should usually stay pure during such events. According to Caltech, these molecules shouldn't normally survive shock waves going faster than 30 to 50 kilometers per second. So naturally, the team wondered what the deal was. This brings us back to the wild chaos we talked about earlier. As they explained, the space the shock wave is plowing through is a bit lumpy, and these lumps seem to break into smaller bits called cloudlets as the shock wave moves along. These cloudlets are where the mysterious hydrogen glow comes from, and they end up becoming part of the shock wave itself. In simpler terms, it seems like the hydrogen in the region is getting reused in both warm and cold gas surrounding the shock wave. Back in 2006, when they were watching the wave, the team found all that regenerated hydrogen. According to them, this is important because molecular hydrogen is the basic building block that could eventually form stars. So figuring out its destiny will give us more insights into the evolution of Stephan's quintet and galaxies overall. Moreover, because of this recycling process, all this intense activity leads to what we refer to as unexpected formations. As the shock wave moves through its chunky obstacles, a stream of heated molecular hydrogen gas links 2 chilly clouds in one of these strange shapes. Picture a speeding bullet slicing through a cloud and leaving a ring-shaped trail behind. The other structure resembles the tail of a newborn galaxy. What we're witnessing is the breakdown of a massive cloud of cold molecules and superhot gas. Interestingly, it goes through cycles of warmth and chill, and while we're still grasping the details of these cycles, we can deduce that the gas is getting recycled because the tail lasts longer than it takes for the clouds it's made of to vanish. Moving forward, scientists' upcoming plans involve utilizing spectroscopic investigations to meticulously monitor the movement of all the gas surrounding the shock wave. By doing so, they aim to determine the speed at which the gas is moving and how it's being heated or cooled as the shock wave travels through the area. These recent findings have given us some new insights, but they've also shown us that there's a lot more out there waiting to be discovered. Basically, we've only just started to learn bits of this story. It's time to dig deeper and find out more. Looking forward, if Elon Musk had the chance to control the James Webb Space Telescope, He said he'd aim it at a random spot in the universe. This way, the telescope, which is helping us understand space in new ways, could find things and answer questions that we haven't even thought about yet without being limited by what we expected to find. But do you think Musk will ever achieve his dream of outer space? Let us know in the comments below and leave a like for more.